All right, welcome everyone. Today, we're going to step inside the modern factory. But we're not here to look at the machinery or the assembly lines. We're here to look at the math that drives it all. We're going to explore a really fundamental tool that the world's most successful companies use to optimize, well, every single aspect of their production. And it's not some new management fad. It's a core principle from a field you might not immediately connect with manufacturing: calculus. Let's dig in and see how this powerful branch of mathematics really creates a massive competitive advantage. So let's think about this for a second. When a company's board decides to ramp up production from, say, 9,000 units to 10,000, is that just a gut feeling, a guess, a simple reaction to what they think the market wants? For the top players, the answer is always a firm no. It is a calculated, strategic move. The secret really lies in applying mathematical principles to find that perfect balance between production cost, efficiency, and of course, maximizing profit. This isn't about intuition, it's about precise calculation that gives them a competitive edge they can actually defend.
Okay, so let's get into our analysis. To really understand how companies achieve this incredible level of precision, we first have to establish the foundational mathematical concept that holds up all of these critical business decisions.
And here it is, our core concept. The central tool we're talking about is a branch of calculus known as differentiation. Now, before your eyes glaze over, I want you to just think of differentiation as a powerful analytical lens. Businesses use this lens to look at their production processes, which, believe it or not, can be modeled as mathematical functions. By applying differentiation, they can see exactly how a change in one variable, let's say an input like labor hours or raw materials, affects an output, like the number of cars they produce. At its heart, it's all about analyzing the relationship between inputs and outputs with incredible, pinpoint precision. So what exactly is differentiation in a business context? Well, in academic terms, it's a method for finding the instantaneous rate of change. Imagine your production output is a curve on a graph. Differentiation lets you find the slope of that curve at any single point. Now, in practical terms, this means you can measure the impact of a very, very small change. For a business, this is basically a superpower. It allows them to think at the margin, to understand with absolute clarity how adding one more worker, running a machine for one more hour, or producing just one more item will affect their overall costs and profits. Now let's move on to our first real-world application. We're going to see how this superpower of differentiation is used to solve one of the most fundamental challenges in any business operation. This, right here, is the classic optimization problem. Think about it. If you underproduce, you leave money on the table. You fail to meet demand. But if you overproduce, you're stuck with huge storage costs, the risk of your products becoming obsolete, and you've tied up capital that could be used for something else. There has to be an optimal point, right? A sweet spot that absolutely maximizes profitability. The big question for any operations manager is, how on earth do you find that exact number? Well, the solution is found by developing and analyzing a very specific mathematical model called the marginal cost function. I know, the name sounds a bit technical, but the idea behind it is incredibly intuitive. This function is literally the key that unlocks the answer to finding that optimal production level. Now pay close attention here because this is a critical insight, and it's where I see a lot of students get confused. The focus is on a single additional unit. Marginal cost has nothing to do with average cost or total cost. It is exclusively about the cost of producing just one more item. We're asking, is the 1,001st unit cheaper or more expensive to produce than the 1,000th? A very common mistake in business analysis is to rely on average cost, but that can be so misleading. Your average cost might be low, but if the cost of that next unit is through the roof, you could be producing yourself right into a loss. The marginal cost function is what truly informs the entire production strategy. And here's how it's done, laid out in 3 steps. First, the company's analysts create what's called a cost function. It's a mathematical equation that models all their total production costs. This will include fixed costs, like rent for the factory, and variable costs, like raw materials. Second, they apply differentiation to this total cost function. This is the calculus part, and what it gives them is that marginal cost function we just talked about. It essentially pulls out the rate of change of cost from the total cost model. And finally, step 3, they analyze this new function to find its minimum value, the point on the graph where the marginal cost is at its absolute lowest. That corresponds to the most efficient level of production. That's it. That is the sweet spot. That's the target number of units they should aim to produce. But finding the point of minimum cost is only one piece of this optimization puzzle. There is another equally important question that calculus helps us answer, At what point does adding more actually become inefficient?
We're all familiar with the idea of too much of a good thing, right? Well, in economics and manufacturing, this is a very real and a very costly problem. It's known as the law of diminishing marginal returns. Basically, at a certain point, adding more variable inputs, like more workers, to a fixed input, like your factory building, will eventually lead to a decrease in the marginal output per worker. The huge challenge is figuring out where that tipping point is before it starts to tank your profits.
So this concept is called diminishing returns. It's that tipping point where adding more resources starts to create bottlenecks. Your factory gets too crowded, your supply chain gets strained, and adding one more worker might just mean that people are getting in each other's way. Now here's a crucial distinction that students often miss. Your total output might still be going up, you're still making more stuff, but the rate of increase gets smaller and smaller for each new resource you add. The benefit you get from each new investment is shrinking.
Now here's the really crucial point. Businesses do not have to find this point through expensive trial and error. By applying differentiation to their production function, they can calculate the exact moment that diminishing returns will begin to kick in. In calculus, this often means looking at what's called the second derivative, which tells us about the rate of change of the rate of change. It essentially finds the peak of the efficiency curve. This allows them to see this cliff edge in their data before they walk right over it, which lets them scale their operations intelligently without falling into this classic economic trap.
And this slide illustrates the principle perfectly. On the left, we have efficient production. This is the zone of increasing returns. You add a worker, and the output from that worker, the marginal product, is significant. Awesome. On the right, you've crossed the line into diminishing returns. You add another worker, but because of all those constraints we talked about, their marginal product is tiny, maybe even negligible. Suddenly, the cost of their salary is more than the revenue they're generating. Knowing precisely where this line is drawn is absolutely fundamental to sustainable, profitable growth.
Okay, so let's pull all these concepts together. We've seen how calculus can find the perfect production level and also warn us when to stop expanding. So why is this framework so incredibly powerful in a business context?
It really comes down to this core principle. Look, any company can try to increase output by just throwing more money and more people at the problem. But the most competitive, most profitable companies on the planet don't just work harder, they work smarter. Mathematics, and specifically the tools of calculus we've been discussing, provides the actual blueprint for making these strategically sound decisions.
So, the key takeaways from our discussion today are pretty clear. By using a single mathematical tool, differentiation, businesses can model and optimize their operations to minimize costs, maximize efficiency, and pinpoint that perfect production level. It lets them proactively avoid waste, and, maybe most importantly, it lets them replace subjective guesswork with precise, data-driven decisions that have a direct and measurable impact on their bottom line.
And that really leaves us with a final thought to consider. We've seen how one specific branch of mathematics can be used to fine-tune an entire industry. And that kind of forces us to ask what other hidden equations and mathematical models are out there, quietly shaping our supply chains, our financial markets, and even our daily lives, just waiting for us to understand them.